Hey, grade 10s. So for those of you that are still confused about the solubility chart, this is just a little bit of a recap. We're going to give this a go, okay? So this is what you're looking at on the back of your periodic table. So to understand how this works, is we need to first be able to identify our cations and our anions in a compound, okay? So the best way to go about this is to look at an example. So if we're to look at PbI4, okay? So I am going to identify that my I4 is actually I negative and Pb is Pb4 positive, okay? So for the most part, when we use our solubility chart, we are looking at, the first step is finding our anion. There's only one cation on the whole thing, which is a polyatomic, okay, NH4 positive, which is ammonia. So how do I work this thing? What's it for? Your solubility chart is to be able to identify whether an ionic, it has to be ionic compound, is actually soluble in water or if it would form a precipitate. So if I was to look at this example, I want the one negative. So I found it right there. Okay, so there's my anion. Now I need to find my cation that is in the compound, so Pb4 positive. So it's either going to be in this part or it's going to be in this part. Pb4 positive is actually found in the most category. Yeah, that was a little excessive. Okay. Which means, okay, that if we look across, it is highly soluble. So in other terms, what this means for the state is that it is aqueous, which means it dissolves in water very easily. Now, if it happened to be found in the low solubility side, so if it was Pb2 positive, it would have been found down here, this would end up actually being a solid. So I would write my compound PbI4, and because it was high soluble, this would be a Q. Okay, so let's look at another example. Use a different color. Actually, here we'll do an erase quick. So if I am looking at NaCO3, so this is my cation Na plus, and my anion is CO3 2 negative. So I need to find my anion. So I should find it over here in my last column. Now I'm going to drop down and figure out where Na positive falls. It actually ends up falling in group 1, and this is just a little reminder of our periodic table. Our group 1 is our first column. Okay, so sodium is in our first column. So that means that this is high solubility, and that means it's an aqueous state. So I would write my compound AQ. Looking at our next example. FeOH3. So in order for this to be, now iron does have 2 possible charges, but because this is hydroxide, OH negative, and there's 3 of them, that means that iron has to be 3 positive. So this is where I now find my anion, OH negative, and I'm going to find Fe3 positive. It is not in a group 1, it's not in the first column, it's not in any of these guys, which means it falls under the most. So anything that's not up here means it's in the most, which means it's low solubility, and therefore I get to put the state as a solid. Okay, so let's give this a go for our next question. There is an assignment that you guys got with this, but if you weren't there for it, if you want to practice, let me know, send me an email and I can email it to you. Looking at this compound, barium hydroxide 2, I would identify barium as Ba2 positive. OH, there's 2 of them, but that just tells me it's a negative. Now, I would go back to my solubility chart. Okay, I'm going to find OH, find barium, Ba2 positive. Okay, that's in my first row here, so that means high solubility. So I am looking at high solubility, and if I had to write the state of it, this would be aqueous. Now, looking at, for example, a PbI2, this is one that it is a multivalent, so you do have to be careful. I is one negative. There's 2 of them, so this is Pb2 positive. So going back to my solubility chart, find I negative, Pb2 positive. This falls under low solubility, and therefore this would end up being low, or in state form, solid. Okay. Hope that answers any questions for you that are a little confused on that topic. Let me know if you'd like me to do a couple more examples, or pop into a Zoom and we can clarify even more. Okay, thanks guys, bye.